Hello dear students, this is Vijay Lakshmi. Welcome to Vinma's YouTube channel. Here in this session, we will discuss the concept continuity and differentiability for second PUC. Here this YouTube channel helping students across Karnataka to excel in their UC board exam and competitive exam. Okay, here we will discuss the concept continuity and differentiability. Here we already studied the differentiability concept, but here in this session we have to discuss the concept of parametric equation. Here there are two functions are there, x is equals to f of t and y is equals to f of t. Okay, the relation between two variables is neither explicit function nor implicit function, but sum of the links of third variable with each two variable separately established a relation between first two variables. Here there is a first function x is equals to f of t, and I consider another one function y is equals to g of t. Here there is a connection between the third variable is called as a parameter. The third variable, okay, we say that the relation between these them expressed via third variable, this third variable is called as a parameter. A relation expressed between two variables x and y. Here there is a relation between x and y. Then x is equals to f of t and y is equals to g of t is said to be a parametric form with the parameter t. We have to use the parameter, have to differentiate the function. Then after finding the differentiation by using the parameter, we can find the dy by dx. Okay, here there is a dy by dt. Okay, now I can differentiate y is equals to g of t function. I can differentiate by using the parameter. Differentiate with respect to the parameter, we can get dy by dt is equals to, here I can return g of t. It can be other than, we don't have any factor here. Before going to that, I will take dy by dt. It can be written as dy by dx and also taking dx by dt. Okay, here I am taking multiplication and divided by numerator and denominator by dx. Here also dx and here also dx. So I can written dy by dt is equals to dy by dx into dx by dt. We want dy by dx only. That's why I'm taking here dx by dt on this side. It becomes divided. Hence I can say dy by dt whole divided by dx by dt. Okay, but always dx by dt has some values. Okay, that is dy by dx can be expressed dy by dt divided by dx by dt. There is a parameter t. Have to differentiate by using the parameter, and whenever dx by dt does not equals to 0. Okay, next, thus dy by dx is equals to g dash of t divided by f dash of t. Okay. Similarly, I can take uh, g of t. While differentiating g of t, it becomes g of t. Therefore, g of t becomes dy by dt. Again, therefore, f dash of t becomes dx by dt. Let's move on the example. When we solve the example, we will know the complete concept. Okay. First, they given find dy by dx if x is equals to a cos t, y is equals to a sin theta. Here, first we have to take the x is equals to a cos theta and differentiate with respect to theta. Then dx divided by dt is equals to, while a becomes constant, I will take differentiation with respect to theta into cos theta. Then it becomes a be a constant, differentiation of cos theta um, becomes minus theta. Okay, with respect to theta, so that is minus a into sine theta dx by d theta. Similarly, I will consider y is equals to a sine theta. Then here also we can differentiate with respect to the parameter. It becomes theta. Then dy by d theta is equals to a becomes constant. Differentiation of sine theta will be cos theta. Okay, then dy by d theta is equals to a cos theta. After that, finding dx by d theta and dy by d theta, but we want dy by dx only. That's why I am taking dy by d theta. There is a common parameter and dx by d theta. Taking the values a cos theta divided by minus a sin theta. Here a get cancelled. We have minus a cos theta divided by sin theta. Cos theta divided by sin theta can be written as minus cot theta. This is the solution of the given example. Let's move on the next one example. Find dy by dx if x is equals to 80 square and y is equals to 280. Here there is a parameter t. So first I can take x is equals to 80 square and y is equals to 280. Okay. Then I have to differentiate with respect to the parameter t. Okay. Here dx divided by dt is equals to a becomes constant. Again d by dt of t square. Then it becomes a into differentiation of t square. It becomes 2t. Therefore dx by dt is equals to 8. Similarly, differentiate y with respect to theta. Then dy by dt is equals to 2a becomes constant. Again d by dt of t. Now dy by dt is equals to 2a into dy by dt of t becomes 1. Therefore dy by dt is equals to 2 into a. That's why we want dy by dx. It becomes 2a divided by 280. 2a get cancelled. We have 1 by t. Therefore, dy by dt is equals to 1 by t. Similarly, we can consider the next one example. Example number 3. Okay. Now, let's consider x is equals to a into theta plus sine theta. There is a parameter theta. So, I can differentiate with respect to theta. Dx divided by d theta is equals to a becomes constant. I can take each term by differentiation. Theta plus d by d theta of sine theta. Okay, now it becomes a differentiation of t with respect to d theta. It becomes 1 minus differentiation of sine theta. It becomes cos theta. Here there is a positive a into 1 plus cos theta. Similarly, y is equals to a into 1 minus cos theta. Differentiate by using the parameter. It becomes dy by d theta is equals to, here there is a will be constant. I can take differentiation separately. D by dt of 1 minus d by dt of cos theta. Then it becomes a into differentiation of constant. It becomes 0 minus differentiation of cos theta minus sin theta. Here a different minus into minus plus it becomes cos theta. We want dy by dx. That's why I am taking dy by d theta whole divided by dx by d theta. Substituting their values, we will get a cos theta divided by a into 1 plus cos theta. Okay, here a get cancelled. We have cos theta divided by 1 plus cos t. Okay, this is the solution. Now let's move on the exercise problem. Exercise 5.6. First one, find the dy by dx if x is equals to 2at square, y is equals to 4at to the power 4. Okay, here I am consider x is equals to 2at square. Now differentiate with respect to the parameter. Differentiate with respect to the parameter t, then it becomes dx by dt is equals to 2a into differentiation of t square. Okay, then it becomes 2a into differentiation of t square with respect to t becomes 2t. Then we have 4at. Therefore, dx by dt is equals to 4at. Again, we want y. Y is equals to 4a t to the power 4. Differentiate with respect to t, then it becomes dy by dt is equals to 4 into a differentiation of t to the power 4. Okay, here 4 into a differentiation of t to the power 4 becomes 4 into t cube. We have dy by dt is equals to 16a into t cube. Then we want dy by dx. That's why I'm taking dy by dt divided by dx by dt. Then it becomes 16a into t cube divided by 4 into a t. Here 4 ones are 4 fours are 16, a get cancelled. There is a t. Here t cube, t get cancelled. We have 4t square. This is the solution of the given problem. Let's move on the next one problem, that is dy by dx. Find dy by dx if x is equals to a cos theta, y is equals to b cos theta. First, let us consider x is equals to a cos theta. Differentiate with respect to the parameter theta. Okay, here there is a parameter theta. I can differentiate, that is dx by d theta is equals to, here a will be the constant, differentiation of cos theta becomes minus sin theta. It becomes minus a into sin theta. We have dx by d theta is equals to minus a sin theta. Similarly, y is equals to b cos theta. Again, I can differentiate with respect to the parameter theta. It becomes dy by d theta is equals to, b becomes constant, differentiation of cos theta again minus sin theta. Dy by d theta is equals to minus b sin theta. Therefore, dy by dx is equals to dy by d theta whole divided by dx by d theta. Now we can substituting the values. It becomes minus b sin theta whole divided by minus a into sin theta. Here minus get cancelled. Sin theta will be get cancelled. We have b by a. Therefore, dy by dx is equals to b by a. Let's move on the next one problem, that is question number 3. Find dy by dx if x is equals to sin t, y is equals to cos t. Okay. First, I can consider x is equals to sin t. I can differentiate using the parameter differentiate with respect to t. Okay, by using the parameter t, then dx by dt, I can written differentiation of sine theta. It becomes cos theta. Similarly, I am considering y, that is equals to cos 2 theta. Again, differentiating by using the parameter that is with respect to theta. dy by dx t is equals to differentiation of cos theta. It becomes minus sine theta. In place of sine theta, we have 2t. That's why I take again differentiation with respect to t. Then it becomes minus sine 2t into differentiation of 2 becomes constant. Again d by dt of t. Then it is minus 2 sine 2t into differentiation of d by dt of t. It becomes 1. That is 1. dy by dt is equals to minus 2 sine 2 theta. We want dy by dx. That's why I'm taking dy by dt divided by dx by dt. It becomes minus 2 sine 2t divided by cos t. I can simply taken as sine 2 theta can be written as 2. Sine 2 theta can be written as 2 into sine t cos t. It is double angle formula. We already know the formula, that is sine 2x is equals to 2 sine x into cos x. Okay. That's why I am taking sine 2 theta 2t is equals to 2 into sine t cos t divided by cos t. Then cos get cancelled. We have minus 4 sine. This is also right answer. This is also right answer. Both are correct. This is the simplified form of this equation. That is dy by dx. Both are correct. Next one. Move on the next one problem. That is find dy by dx if a is equals to cos theta and b is equals to cos theta. We already done this one. Then exercise number 5. Find dy by dx if x is equals to 4t and y is equals to 4 by t. Here, first I am taking x is equals to 4t. Differentiate with respect to the parameter t. I can differentiate dx by dt. Here, for differentiation of t with respect to t, it becomes 1. Therefore, dx by dt is equals to 4. Similarly, y is equals to 4 divided by t. Again, differentiating with respect to t, I can written dy by dt is equals to 4 becomes constant. D by dt of 1 by t. Differentiation of 1 by t. Okay, here I can written 1 by t is equals to, taking t on the numerator, it becomes t to the power minus 1. Again, I am using the formula differentiation of x is equals to, with respect to x is equals to n into x to the power n minus 1. Here also I am taking differentiation with respect to theta. Sorry, t. Okay, then I am taking replace n by minus 1. It becomes minus 1 t to the power minus 1 minus 1. Then it becomes minus t to the power minus 2. Again, I am taking t to the power minus 2 on denominator. It becomes 1 by t square. That's why I am taking differentiation of d by dt is of 1 by t is equals to minus 4 divided by t square. Okay. Therefore, dy by dt, dy by dx is equals to dy by dt divided by dx by dt. Next, dy by dt is equals to minus 4 by t square whole divided by dx by dt. It becomes 4 by 1. Simply, I can take 4 by 1 by using the denominator rule. Minus 4 can be multiplication here, and again 1 is multiplication here. Then it becomes minus 4 into 1 divided by 4 into t square. Okay, 4 get cancelled. Then it can be written as minus 1 by t square. Therefore, dy by dx is equals to minus 1 by t square. Okay, now let's move on the next one problem, that is differentiation. Find dy by dx. Okay, here find dy by dx. Here there is a question number 5. I can take here x is equals to cos theta minus cos 2 theta. Here x is equals to cos theta minus cos 2 theta. Okay, I can differentiate with respect to the parameter theta. It becomes dx by d theta. I can differentiate d by d theta of cos theta minus d by d theta of cos 2 theta. Then differentiate. Differentiation of cos theta becomes minus sin theta. Here also there is a minus. Again differentiation of cos 2 theta minus sin 2 theta. In place of theta we have 2 theta. That's why I am taking again differentiation of 2 theta. It becomes minus sin theta. Minus into minus becomes plus sin 2 theta into differentiation of, it is 2 into differentiation of theta becomes theta. Then dx by d theta is equals to minus sin theta plus 2 sin 2 theta. Again taking y. Y is equals to sin theta minus sin 2 theta. Now differentiate with respect to theta, then it becomes dy by d theta is equals to differentiation, taking differentiation for each term, differentiation of sin theta minus d by dt of sin 2 theta. Okay, here differentiation of sin 2 theta becomes cos theta minus, again differentiation of sin theta, it is also cos theta. In place of cos theta we have cos 2 theta. That's why I'm taking again differentiation to theta. Then cos theta minus cos 2 theta into, therefore dy by d theta is equals to cos theta minus 2 cos 2 theta. But we want dy by d theta, I can take minus sin theta plus 2 sin 2 theta divided by cos theta minus 2 cos 2 theta. This is the solution. Number 7, that is x is equals to sine cube t divided by cos cube t. Then y is equals to cos cube t divided by root of cos 2t. First, I will take x is equals to sine cube t divided by root of cos 2. Now, I am taking the u divided by root. That is quotient rule, u divided by v. Here, have to differentiating the first function, second function constant minus second function differentiation, first function constant and differentiate divided by v square. Okay. Here, I am also taking the first function constant here. Okay, differentiate with respect to the parameter, differentiate with respect to the parameter t, then dx by dt is equals to, first have to differentiate sine cube theta. Okay, d by dt of sine cube t and simply constant taking root of cos 2 t minus d by dt of root of cos 2 t into taking sin cube t as a constant. Okay, now whole divided by root of cos 2 t whole square. Now differentiation of sin cube t. Sin cube t becomes 3 into sin square t, and again in place of x we have sin theta. We can take sin. Here sin cube t in terms of x cube. So I can take cube first. First differentiate cube. It becomes 3 into sin square t. Again in place of x we have sin cube t. That's why I'm taking differentiation of sin theta into root of cos 2 t minus, here of the form root x. In place of x we have cos 2t. That's why I'm taking 1 divided by 2 into root of cos 2t into differentiation of t. In place of x we have cos 2t. That's why I'm taking cos 2t into sin cube t whole divided by, here root and square get cancelled. We have cos 2t. Now again here 3 sin square t into differentiation of sin t becomes cos t. Again root of cos 2t minus 1 divided by 2 into root of cos 2t and differentiation of cos, it becomes minus sin 2t. Again in place of t we have 2t. That's why again differentiation, it becomes 2 into sin cube t. This 2 cancel. Again here minus minus get plus divided by cos 2t. Okay, we have dx by dt is equals to, taking here, taking LCM of the numerator. Here there is a root it becomes, root get cancelled, 3 sin square t cos t. Here multiplication of root in this side, it becomes cos 2t. Then root of cos 2t I am taking denominator. Minus into minus plus, it becomes sin 2t into sin cube t divided by cos 2t into root of cos. While taking the LCM, I can take the root of cos 2 theta multiplication here, then whole equation divided by root of cos t. By using the law of denominator, I can take denominator, that is cos 2t into root of cos 2t. Now, similarly, this is dx by dt. Similarly, for dy by dt, it is also cos cube t divided by root of cos 2t. I can differentiate by using the u by v quotient rule, that is dy by dt becomes, first here there is a y only, sorry, here there is a y only, y becomes cos cube t divided by root of cos 2t, dy by dt, have to differentiate first function d by dt of cos cube t into root of cos 2t minus d by dt of root of cos 2t into cos cube t whole divided by root of cos 2t whole square. Okay, now d by dt of cos cube t, it becomes 3 cube of cos t, 3 cos square t, in place of x we have t, that's d by dx of by using the parameter d by dt of cos t into root of cos 2t minus differentiation of cos 2t. It becomes 1 divided by root of cos 2t. Again differentiate with respect to cos 2t into cos cube t. Then whole divided by root. Here there is a root get cancelled. We have cos t only. We have cos 2, that is cos 2. Then the equation becomes 3 into cos cube, cos square t. Differentiation of cos will be minus sine. Here I am taking minus sine minus 1 divided by 2 into root of cos 2t. Differentiation of cos 2t, again minus sine 2t into 2 cos cube t whole divided by cos 2t. 2 get cancelled. Here minus into minus becomes plus. That is minus 3 cos square t sine t minus he. Okay. Here there is a, I'm missing this term, cos 2t into root of cos 2t minus into minus, it becomes plus, that is sine. There is a sine 2t into cos cube t divided by cos 2. Then finally dy by dt is equals to minus 3 cos square t sin t, multiplication taking LCM, it becomes cos 2t plus sin 2t cos cube t divided by cos 2t into root of cos 2t. We have dx by dt and dy by dt. Then have to calculate, then have to calculate dx by dt. Now dy by dx becomes dy by dt divided by dx by dt. Here have to substitute dy by dt equation, then also dx by dt equation. In this equation, get answer. This is the solution of the given problem. Okay, you have to substitute and find the answer. Next one, here this is the important one. Okay, here this is the one of the important problem. Exercise number 8. X is equals to cos t plus log of tan theta by 2. Y is equals to a into 1 plus cos t. I will solve here. X is equals to cos t plus log of tan t by 2. There is a parameter t. Differentiate with respect to t only, that is dx by dt is equals to d by dt of, I can take differentiate separately, cos t plus d by dt of log theta by 2. Now, differentiation of cos t, it becomes minus sin t plus differentiation of log, that is 1 by x. In place of x, we have t by 2. And again, I will differentiate t by 2 becomes minus sin t plus, I can take t by 2, it becomes 2 by t, and differentiation of t by 2. We are taking 1 by 2 as a constant, then differentiation of t will be 1. Therefore, 2 to get cancelled, minus sin t plus 1 by t. Therefore, dx by dt is equals to minus sin t plus 1 by 2. Then y is equals to differentiation, a is equals to 1 plus cos t. Again, by taking the differentiation with respect to the parameter t, then dy by dt is equals to, a becomes constant. Again, differentiation of, I am taking separately d by dt of 1 plus d by dt of cos t. Now, a becomes constant, differentiation of 1, it becomes 0 plus differentiation of cos t, it becomes minus sin t, a into minus a into sin t, that is dy by dt. Therefore, dy by dx is equals to dy by dt whole divided by dx by dt. It becomes minus a sin t divided by minus sin t plus 1 divided by. This is the solution of the given problem. This is the solution of the given problem. Next one. Okay. This is the homework problem for you. Have to solve this. Okay. Then 10th one. This is also one of the important. Okay. This is also one of the important question. Have to solve homework problem. Have to solve these homework problems and send in comment box. Okay. And then last one, question number 11. This is the one of the important problem. Most of the time the problem will be ask for 3 marks. First, I can consider x is equals to root of a to the power sine inverse of t. Then again differentiate with respect to t. Okay. Then dx by dt is equals to differentiation of root. What is the differentiation of root x? That is 1 divided by 2 into root x. In place of x, we have a into sine inverse of t. Okay. In place of x, we have sine inverse of t. That's why I'm taking again differentiation with respect to a into sine inverse of t. Okay. Here in place of x, we have a. Now, 1 divided by 2 into root of a to the power sine inverse of t. Here, differentiation of a to the power x. Okay. Here, differentiation of a to the power x, it becomes ax into log a. Okay. Differentiation of x with respect to x, it becomes a to the power x into ax into log a. Similarly, this is of the form, here in place of x, we have the parameter. That's why differentiation of a to the power sine inverse t becomes a into sine inverse of t log a. Okay. Here log a. Then in place of x, we have sine inverse of t. In place of x, we have sine inverse of t. That's why I'm taking again differentiation of with respect to t into sine inverse of t. Okay. Then it becomes 1 by 2 into root of a sine inverse of t into a into sine inverse of t log a. Differentiation of sine inverse of t. What is the differentiation of sine inverse of t? That is 1 divided by root of 1 minus x square. Okay. Here in place of x we have t. That's why I can written t square. I can written t square. This is the dx by dt. This is the dx by dt. Okay. Now, similar to that of, now I can solve the y. Y is equals to root of a to the power cos inverse of t. Again, differentiate with respect to the parameter t. Okay. Now, dy by dx is equals to differentiation of root x. It becomes 1 divided by 2 into x. In place of x, we have a into cos inverse of t. That's why I'm taking again differentiation with respect to a into cos inverse of t. Okay. I can take differentiation. Now, I can take the differentiation. Then again dy by dx is equals to 1 divided by 2 into root of a to the power cos inverse of t. Here a to the power x of the form. That's why then I can written a into cos inverse of x into log a. What is it becomes log a, and again differentiation of, in place of x we have cos inverse x. I can differentiate. Now dy by dx is equals to 1 by 2 root of a to the power cos inverse of x into a cos a to the power cos inverse of x log a, differentiation of cos inverse x, 1 divided by root of 1 minus t square. Here, now we have dx by dt, dy by dt. Okay, now we want dy by dx. That's why dy by dx is equals to dy by dt divided by dx by dt. Now I can substituting the values here, that is 1 divided by 2 into root of a cos inverse of x into a into cos inverse of x log a into minus of root 1 minus t square divided by 1 by 2 root of a sine inverse of x into a sine inverse of x log a 1 divided by root of 1 minus t square. Here log a get cancelled. 1 minus root of 1 minus t square, 1 minus t square get cancelled. 1 by 2, 1 by 2 get cancelled. Taking, okay, I can take here a into, okay, here I can take a into cos inverse of x. Here also a into, now x can be written as root x into root x. Again, root x is root of x whole square, then it becomes x only. That's why we have to express the normal values. We have to express the values by using the root. So, I can take a to the power cos inverse x. Here, a to the power cos inverse of x can be written as root into root of a into cos inverse of x divided by, here already there is a into cos inverse of x is there. Similarly, here there is a minus, then it becomes, here also I can written a into sine inverse of x becomes a into sine inverse of x into a into sine inverse of x divided by root of a into sine inverse of x. Here one a sine inverse x get cancelled. Again here also get cancelled. Then it becomes root of minus cos inverse x divided by root of a to the power sine inverse x. What is the? We already know that a into cos inverse of x can be written as y, and here a root of a into sine inverse can be written as x. Okay, therefore we have to prove showing that dy by dx is equals to minus y by x. This is the solution of the given problem. So this much the concept will be completed for parametric equation. Your comments will help to improve my next class better than this, and also have to solve all the homework problems given to you and send your answer in comment box. If there is a mistake, I will correct it in next section. So please do share, subscribe and like my channel. Give me an opportunity to share my experience with you all. Thank you everyone.